Now let's look at Rolles Theorem. Rolles Theorem states that if f is continuous on a closed interval, all right, and differentiable on an open interval, and if the functional values on the endpoints are the same. So then there is at least one point, not necessarily exactly one, but at least one, C contained within AB, such that f prime of C is 0. So you have to show these three things: continuity, differentiability, and f of A equals f of B. So let's use Rolles' theorem. This is continuous. This function is continuous and differentiable because it's a polynomial. And they want us to find the two x-intercepts. All right, so for that I need to factor. F of x is x minus 1, x minus 2. So f of x equals 0 when x equals 1 and 2. So the one intercept, f of 1, is equal to f of 2, which is 0. So I've just shown that f of A equals f of B. So by Rolles' theorem, there exists at least one point between 1 and 2 so that the first derivative is 0. And let's see if that's true. F prime of x is 2x minus 3. And this equals 0 when x is 3 halves. And lo and behold, 1.5 is indeed between 1 and 2. Now let's look at this one. Find all values of c in the interval such that f prime of c is 0. Well, I know it's continuous, and I know it's differentiable because it's a polynomial. And let me look at what f of negative 2 is. Negative 2 to the 4th minus 2 negative 2 squared. And it turns out this indeed is going to be equal to f of 2. You can use the fact that it's an even function. You see, sometimes you can do this without actually finding the number, but I've been able to show that f of A does equal f of B. All right, so now let's find the values for which f prime of x is equal to 0. So this is 4x cubed minus 2x times 2. So this is 4x cubed minus 4x. So I'm going to factor 4x out of this whole thing. So this is x squared minus 1. So I have 4x times x minus 1, x plus 1. So f prime of x is equal to 0 whenever x is equal to 0, 1, and negative 1.